Welcome to Click Academic. We've discussed continuity. So this is the antithesis of continuity. This is discontinuity. So a function f of x is said to be discontinuous at a point x naught if it is not continuous at that point. It's just quite simply the opposite. If it is not continuous, then it is discontinuous. That is just logical now. You can understand that straightforward. So we have two types of discontinuity. We have removable discontinuity. So for a function to have removable discontinuity, f of a will not be defined. You remember we talked about conditions. F of a must be defined, limit x must exist, and limit must be equal to f of a if it's continuous. So for discontinuous, f of a is not defined. So you can see quite simply it's not continuous, but this discontinuity can be removed. Then for the second, non-removable, f of a is not defined and the limit does not exist. So this is just quite simply discontinuous and there's nothing we can do about it, at least at this level. So we'll just try some examples to see how this pans out. Let's just see what we're talking about when we're talking about removable and non-removable. So for example 1, the solution will go like this. We said we should discuss the discontinuity of the function defined by this. So our function is f of x is equals to x squared minus 4 divided by x minus 2, and we are to find the continuity at x equals to 2. So the point is 2. So first we find f of a, we said. So our f of a is equals to 2 squared minus 4 divided by 2 minus 2. So this is just 4 minus 4 divided by 0. This is 0 divided by 0. So we see this is undefined. So f of a does not exist. So we already know that this function is not continuous, but we know it is discontinuous because f of a does not exist, so it can't be equal to the limit. But so does the limit exist? That's what we check next to know if it's removable or not. So the limit as x tends to 2 of f of x, our f of x is x squared minus 4 divided by x minus 2. So we see that if we substitute 2 in here, like we did previously, it's going to be 0. And we try to avoid division by 0 when we are talking about limits. Here, there was nothing we could do, and we're not allowed to manipulate here. So here, we have to resolve this denominator issue. So from here, I can simply write this as x minus 4. I can see that my x minus 4, I can write this as x squared minus 2 squared divided by x minus 2, which is the same as limit as x tends to 2 of, this is the difference of 2 squares, so I can just write this as x minus 2 into x plus 2, all divided by x minus 2. So from here, my x minus 2 cancels the one at the top. So this is limit at x tends to 2 of x plus 2. So this limit is just simply equals to 2 plus 2, which is 4. So my limit exists, but f of a is undefined. So we can see this function is not continuous, but the discontinuity is removable. So for the second, we said we are to discuss all points of discontinuity. We are to obtain all the points for this function, x squared minus 4 divided by x squared minus 5x plus 6. This is as x. Okay, we are to obtain discontinuity, right? So at what point are these functions discontinuous? Quite simply, all we have to show is when this denominator is equal to 0. So we solve this quadratic equation at the bottom. We'll show that at the points at the solution, that's the roots of this equation, this function is not continuous because it will be divided by 0, and f of a at that point will not exist. So I can rewrite this as x squared minus 4, or let me consider the denominator only. So I'll consider x squared minus 5x plus 6. So solving quadratic equations, we know that first I look for something that when I multiply, I'll get this, and when I add, I'll get this. And quite simply looking at this, you say that is minus 3 and minus 2. Minus 3 times minus 2, this is plus 6. Minus 3 plus minus 2, minus 5. So I can rewrite this as x squared minus, let's say 2x minus 3x plus 6, which will be equal to x squared minus 2x. If I separate these, it's going to be minus 3x minus 6, which, this is the same. So I factor my common factors out. This is going to be x minus 2 minus 3 into x minus 2. This quite simply is the same as x minus 3 and x minus 2. So this implies x minus 3 is equals to 0 or x minus 2 equals to 0. So x is equals to 3 or x is equals to 2. So at these points, my f of a is undefined at these points, because at these points the denominator is going to be 0. So we simply find which one is continuous and which one is not. So we are to discuss the nature of discontinuity at each point. We know that this f of x is not continuous at 3 and not continuous at 2. So we find, are both of them removable, or are both of them not removable, or which one is removable and not. So we just quite simply try it out. I'll do it on the next page. So my function is x squared minus 4 divided by x squared minus 5x plus 6. So I've written this already as x squared minus 4 divided by x minus 3, x minus 2, right? This is standard. So we already know that at my limit at 3 or 2 is going to be 0. So I don't need to find the limit here. I already know. When I substitute 3 or 2 into this, I already know it's going to be 0. So I don't need to substitute f of a here. I already know it's 0. It's undefined rather. So I need to find my limits. So my limits as x tends to 3 is x squared minus 4. Limit of f of x is equals to limit as x tends to 3 divided by x minus 3, x minus 2, which is the same as limit as x tends to 3 of, we remember my difference of two squares, this is going to be x minus 2, x plus 2, divided by x minus 3, x minus 2. So I strike these out. This is just limit as x tends to 3 of x plus 2 divided by x minus 3, which is, when I take my limits, this is going to be 3 plus 2 divided by 3 minus 3, which is 5 divided by 0, which is undefined. Or we can sometimes we say infinity, but this is undefined. So we know that now my limit at x tends to 3 does not exist. It's undefined. So since this is undefined, my limit, my discontinuity at x equals to 3 is not removable. So we try it at x as x tends to 2. So limit as x tends to 2 of f of x, which is equals to limit as x tends to 2 of, I'll just pick this spot so that I don't repeat myself too much, x minus 2, x plus 2, divided by x minus 3, x minus 2. So this, my x minus 2 cancels this out. So this is limit as x tends to 2 of x plus 2 divided by x minus 3. This is, when I take my limits, it's going to be 2 plus 2 divided by 2 minus 3, which is 4 divided by negative 1, which is equals to negative 4. So my limit at x tends to 2, limit as x tends to 2, we see that it exists. It's a negative number, negative 4, even though my f of a at f of 2 does not exist. My f of 2 does not exist, but my limit at x tends to 2 exists. So we say that this discontinuity, that is the discontinuity at x as x tends to 2, is removable. So that brings us to the end of this lesson. Thank you.